And I had told you that we can say L is equal to somehow my pen is not writing. Can you see L is equal to I omega?
Yes, sir.
Okay, okay, fine. Now this is a vector, this is a tensor of order 2, this is another vector. This I had told you this is a matrix having 9 terms, and this is a symmetric matrix. Okay. So we have a rigid body. Then suppose I want to find time derivative of angular momentum. What will be this time derivative? I'll have to use,
सर आई तो सर कांस्टेंट से आई बाहर आ जाएगा और बाकी डी ओमेगा बाई डी टी हो जाएगा.
but I need not be a constant. I will just explain. So if you take its time derivative, then if you use product rule of differentiation, di by dt omega plus I bar. Now this is your rigid body. This is your coordinate system. Now as this body rotates, its the moment of inertia tensor is also changing. You see, I had done the case of a rod, and this angle was theta. What was my I-axis? It was some ml square by 3 cos square theta. If my rod is rotating, then I-axis will also keep changing as theta changes. So I-axis is a function of time if theta is a function of time. So we cannot say that our moment of inertia tensor is a constant. How it can become a constant? Anybody? Now what we do? Now we have a rigid body. We have a fixed coordinate system, and we take a embedded coordinate system. Now, as the rigid body rotates, this embedded coordinate system is rotating with it. So you see, then my I matrix with respect to 1 to 3 is a constant because position of each particle in the body is same with respect to this coordinate system, which is embedded in the body and rotating with the body. Am I all right?
Yes, sir.
While I x y z, that is not a constant. So now what I have to do? I have to see that I want my time derivative with respect to this coordinate system while I also operate in this coordinate system as far as I is concerned. Now what we do, for example, I take a vector. I have a vector A. So vector A is fixed in this body. It is some vector A. Now, as this body rotates with angular velocity omega, then what is the time derivative of vector A with respect to xyz system? I had told you it is omega cross A. So here what I have taken, this A is in small xyz system, or rather 1, 2, 3 system, and it is fixed. It has a constant magnitude. So this vector is constant in this coordinate system, while it is rotating with respect to this coordinate system. So there are two possibilities. Number one, this vector A also has a variation in this coordinate system. It also changes its magnitude. So I have got two things. I can say dA by dt, capital XYZ, is equal to dA by dt, 1, 2, 3, plus omega cross A. If I say now A is not fixed with respect to 1, 2, 3, then it will have some variation with 1, 2, 3. Plus variation because this 1, 2, 3 is rotating with respect to capital XYZ. So there are two variations in vector A, one with respect to 1, 2, 3 system, another because 1, 2, 3 is rotating with respect to capital XYZ. Any problem?
सर ये मतलब ये 1 2 3 हम वो देख रहे हैं कि एक्स वाई जेड के प्लेन के अकॉर्डिंग ये कैसे चेंज हो रहा है, एंड द अनदर वन इज कि वो उसी 1 2 3 के रिस्पेक्ट में चेंज हो रहा है ये.
Because you have a vector A, we will
यस
take a
सर.
simple situation. So I have this rotating platform. I have a slot in it, and there is a particle moving outward in the slot. Now you see this particle, this slot is fixed with respect to the platform, and this particle is moving in the slot. So an observer stationed here will see that this fellow is moving outward. He has some outward velocity. It can also be accelerating in the slot. Now I will turn this, it is a turntable. So this table is rotating also. So this observer will say, this is having a rectilinear motion. But this observer will say it's a complex motion. Do you agree? So there are two different observers. One is in a rotating system, another is in a fixed system. Any problem?
क्लियर सर.
Okay. So now what do we say? That we have a embedded system with the body, with the rigid body. So in this system, this vector is may have some variation. Plus variation with respect to this system because of rotation of this coordinate system. Okay. Now what we have a body. It has a center of mass. You take any point in the body. Now, what is the velocity of this? What is the position vector of this point? Suppose this point position vector is r, and position vector from the fixed system of this point is capital R. So this is my fixed system, and this is my some rotating system. Now this is my center of mass. Call it this as O. This is my O prime. So what is my this capital R is equal to small r plus O prime. Now we assume that this has a pure translation. One, two, three has pure translation. So if I want to find its time derivative, so my absolute velocity is velocity related to the platform with respect to 1 to 3 plus velocity of the origin of the this embedded coordinate system. Now if I want to find its acceleration, so acceleration with respect to capital system is equal to acceleration with respect to 1 to 3 plus acceleration of the that moving origin. Any doubt? If I multiply with mass of the particle, that is what I get. So mass of the particle, can I write like this? So this is my equation of motion or Newton's second law. So this is Newton's second law as applied to a non-inertial reference frame. So it's an linearly accelerating reference frame. So this is the acceleration of the reference frame. If you sum it over all the particles, this is over particle I. So I am saying absolute acceleration of particle I into mass of that particle minus mi AO prime. AO prime is constant for the entire body is equal to mass of that particle and the relative acceleration of that particle with 1 to 3 system. Any doubt? If I sum it over all the particles, not a problem. So what I get? This is acceleration of xyz with respect to capital XYZ system. So you can say this is mass, total mass, acceleration with of center of mass with respect to XYZ system minus mass, total mass into A naught prime, acceleration of the origin is equal to any problem you see.
No, sir, clear.
So what is this mass into acceleration of center of mass? What is this equal to? This is with respect to a fixed coordinate system or inertial coordinate system. What is this equal to? Newton's second law says this is equal to the external force. Okay. So you see, you had to add an inertial force. This is known as inertial force. To the net external force. Then you can find acceleration of the center of mass with respect to that 1, 2, 3 system. So each particle of the body, you apply a force equal to its mass of the particle and acceleration of the origin. This force acts like a body force. You see, gravitational force, which acts on each particle of the body. Each particle of the body is attracted downwards with acceleration g. So you say force on each particle is mig. G is a vector. And what is the total force? Now g is kind of uniform vector. So sigma mi. So this is the net body force. Now here you see this acceleration of the origin is a constant because your body is translating with acceleration given to the center of mass. Entire body is having the same acceleration, and you have fixed the reference frame to that origin, that moving origin. So when you analyze, you say each particle is having this inertial force. So total inertial force on the body is minus ma naught prime, and this way you can see what is happening to the acceleration of the center of mass. If acceleration a naught prime is equal to acceleration of the center of mass with respect to xyz system, if it is same, then these two terms will become equal, and acceleration is equal to the moving system will be zero. Suppose you are in a car is accelerating. Observer sitting in the car will say that he is having constant velocity. With respect to the car, his velocity was zero. Again, it is zero. Okay. So we will see more some examples of it. But you come to know that each particle gets an acceleration. Each particle gets a force equal to the mass into acceleration of that origin. And you have to put a minus sign. So the net force is now different. It is external force plus this inertial force. And with this force, you can analyze the motion, the acceleration of the particle in the non-inertial reference system. Okay. Now we do what we do. We said dA by dt is equal to dA by dt, that 1, 2, 3 system. This is XYZ system plus omega cross A. This was the stuff we started from. Now we say that this A is equal to linear momentum of the rigid body. Now we can say dp by dt with respect to xyz is equal to dp by dt with respect to 1, 2, 3 system plus omega cross p. This p we are measuring with respect to 1, 2, 3 system. This A we measured with respect to 1, 2, 3 system. Now, any doubt about this? Lavish, any problem with this? This A we have measured with respect to 1, 2, 3 system. It's a vector in 1, 2, 3 system.
Okay, sir.
But we want to find its time derivative with respect to a fixed system. Now, what is this P? Nothing but mass into velocity. You can take as velocity of the center of mass. Now, what is this dp by dt? This with capital XYZ system. You can say M. Now, what is this? Omega. If you write that vector product, omega 1, omega 2, omega 3, and this is what nothing but V1, V2, V3. Can you do like this? I have written momentum of the particle with respect to 1, 2, 3 system. Angular
सर
velocity.
हम तो सर यहाँ पे भी वो कर रहे थे वो ये लीनियर मोमेंटम को वो कर रहे थे, डिफरेंशिएट कर रहे थे, तो सर यहाँ पे मास भी कांस्टेंट नहीं होगा शायद,
Mass
बिकॉज
is
हम
always a constant.
सर एक्स वाई जेड सेट फ्रेम से हम एक पार्टिकल का मास कंसीडर कर रहे हैं,
Yeah.
1 2 3 के अकॉर्डिंग तो वो मास फिक्स हम
I'm not talking of moment of inertia. It is mass. Mass
ओके
is the
सर,
same in every coordinate system.
ओके सर,
Okay, not a problem. So if you expand this term, so what is this equal to? Take the I component, omega 2 V3 minus V2 omega 3. What is your J component? V1 omega 3 minus omega 1 V. What is the K component? Omega 1 V2 minus V1 omega 2. Any problem? So this will be equal to, hello Vipalji, good morning. Can I talk after 15 minutes? I'll call you. Okay, thank you. Okay. So m dv by dt plus this term. Now m dv by dt you can write as m dv1 by dt. So I've written the components. Velocity vector is same as v1, v2, v3. So I have taken this. Do you have any doubt about this?
सो आई थिंक हमें बिग ब्रैकेट का भी यूज करना चाहिए क्योंकि m तो हमने कांस्टेंट बाहर निकाला है ना.
Yeah.
तो सर ये लाइक इसमें मल्टीप्लिकेशन तो हो ही नहीं रहा, जो प्लस के बाद वाले डिजिट है. सही, जो v1 v2 है सर, इसके साथ जो प्लस में जो डिजिट है ओमेगा 2 v3 वाली, सर इसमें भी तो m मल्टीप्लिकेशन में होगा.
Yes. Look, mass into acceleration with respect to that 1, 2, 3 system.
सर मैं कह रहा हूँ सर, ये
अच्छा,
जो सेकंड
I have
डिजिट
left
इसके
out
साथ भी.
omega m.
यस सर, इसमें भी
M.
m
Okay.
मल्टीप्लिकेशन होगा.
Okay. Okay. Good. So this is an m here. Okay. Now it is all right.
यस सर, फाइन.
Okay. Now what is this term on the left hand side? So this is my f1, f2, f3.
यस सर.
The time derivative of momentum with respect to the fixed coordinate system. With force only. Now you assume your P is earlier you had found a time derivative with respect to that 1, 2, 3 system. That is this. This is with respect to that 1, 2, 3 system. And this is that total force because you have found the time derivative with respect to the fixed system. So one equation you can write for coordinate for the direction 1. m omega 2 v3 minus v2 omega 3 plus m dv1 by dt is equal to Fy. Similarly, you have got other equations. Now, what you have done here is you have represented everything in 1, 2, 3 system. You see angular velocity omega. You have represented 1, 2, 3 system. Now, suppose this is a coordinate system x, y, z, and this is a 1, 2, 3 system at a point of time. Now, you will say this body is having angular velocity omega x, omega y, omega z with respect to this coordinate system. Some angular velocity is there. About this axis, it is going around. Now, this axis, what is this axis? It will be given by unit vector of this. What is the magnitude of this? Omega x square plus omega y square plus omega z square. So you divide it by this. So you will get the direction of this axis of rotation. And the magnitude will be this vector, this magnitude. So this is the way you will say this is your this angular velocity with respect to capital XYZ system. But then you have to find this angular velocity with respect to the 1, 2, 3 system. So just any vector you can transform to another coordinate system. That is what you have to do. Because when you will take cross product of some quantity, you are measuring a vector A in this coordinate system. So you will have to do cross product in the same coordinate system. Omega 1, 2, 3 cross A 1, 2, 3. Only then you can do the cross product. Otherwise, you cannot do the cross product. You cannot take omega of this system and vector A of this system and do the cross product. You get my point? Because the unit vectors will be different. Then you cannot do that I, J, K, omega 1, omega 2, omega 3, A1, A2, A3. Now these IJK belong to 1, 2, 3 system. So you have to be very clear about it. Any doubts?
No, sir, clear.
Okay.
So can you please explain this part once again?
We will do it. Not an issue. Now similarly we have got this angular momentum. So what we are doing dl by dt 1, 2, 3 plus omega cross L 1, 2, 3 is equal to torque. So torque is equal to, so this is nothing but dl by dt capital XYZ 1, 2, 3 plus this. So L is equal to I omega. Now if you are having principal axis of inertia, you are taking a rotating system as a principal axis. Okay. Then what will happen to I? L will be I1 omega 1, I2 omega 2, I3 omega 3. All right. What is your angular momentum? L is equal to nothing but I omega. Since I is a diagonal matrix, your L will be this. So this is with respect to that 1, 2, 3 system. Plus you are doing omega cross L. So that again you will do in the same manner as before. I, J, K, omega 1, omega 2, omega 3 And what is your L? I1 omega 1, I2 omega 2. So it should have been this. So this you can find is equal to your M1, M2, M3. Now what is this term? Now you see, since coordinate system is embedded in the rotating body, I1, I2, I3 are constant with time. This thing again you expand as before. Okay. So you get the term M1 is equal to I1 d omega 1 by dt plus I3 minus I2 omega 2 omega 3. You expand this thing, and this is what you get. Suppose I just pick the I term, pick the I omega 1 I3 omega 2 minus omega 3 I1 omega 1. So I3 omega 2 omega 3 I3 omega 1 omega 2 what I have done omega 1 I3 omega 2 omega 3 I1 omega 1 omega 3. So omega 1 you take out, then it becomes I3 omega 2 okay. You have to just check it out. Okay, any questions? Still there are 5 minutes, I can fix it up.
So वो ओमेगा वाला पार्ट प्लीज एक बार वापस बता दो.
So वो ऊपर वाला
Oh, I have messed it up. What is my I? I component is omega 2 I3 omega 3 minus I2 omega 2 omega 3. This is my ith component. So omega 2 omega 3 I can take out. It becomes I3 minus I2. So this equation is all right. Now what I had told you about that, why we are taking coordinates. We have to suppose we have a vector. Now this is a rotating system. I have got 1, 2, 3, and we have got another coordinate system which is fixed. But this fellow is rotating all the time. So if I measure its angular velocity with this system, it will be some omega x, omega y, omega z. Now I want this angular velocity in 1, 2, 3 system. The 1, 2, 3 at a point of time, this is my 1, 2, 3 system. Okay. So this angular velocity vector is suppose about this y-axis. I can take it like this. Now what is its component here? This becomes 0, this becomes 0. If this is some vector, if my axis of rotation is y-axis with respect to this. But now we have to find this direction in this 1, 2, 3 system. In this, suppose this 2 was earlier parallel to this y. So it was like this. But now 1, 2 is like this. So this thing we have to find in terms of this coordinate system. Get it? So this will have now components in direction 1 and 2 also. You get my point? So whatever we used to do with vector transformation, we will first have to apply to this vector to get the components in omega 1, omega 2, omega 3 in 1, 2, 3 system. And if we are measuring any vector here in this 1, 2, 3 system, then you see the unit vector components are same. Only then I can use this I, j, k, or rather I1, I2, I3. I'll have something like this I1, I2, I3. And then omega 1, omega 2, omega 3. And any vector A1, A2, A3. So these two vectors have to be measured in the same coordinate system. Is it all right now? So once we do some examples, it will be more clear. Can I
Okay, sir.
wind up?
सर एक
Somehow
बार सर वो अपर वाला पार्ट समझा देते सर वो लाइक F1 वाला पार्ट
the
हमने
F1,
लीनियर मोमेंटम वो कंजर्व कर लीनियर मोमेंटम वो फाइंड किया था तब
you see, this was in the inertial frame, whatever are the forces. Forces are always in an inertial frame. Forces won't change. External force is external force.
यस सर
But if you want to analyze something with a non-inertial frame, things become different. I'll take a simple example. There is not much time left. So take the case of a particle. This particle is moving with has some force F. What is the acceleration of the particle? F by m. So this is with respect to this fixed value. Now I put a coordinate system on the particle itself. Now what is the acceleration of the particle?
सर
Zero.
0
Now if I apply Newton's second law, I have to take second external force is equal to mass into acceleration with respect to that 1, 2, 3. This is 0. So now something is wrong. Newton's second law has to change. I have to introduce an inertial force equal to whatever is the acceleration of this coordinate system. This coordinate system has acceleration a. Suppose I say a center of mass. So now this f is also equal to macm. Whatever this is what you have calculated. So you see, so you can say acceleration with 1 to 3 is 0. Can you see this? Because you have to
एक्चुअली जब हम उस पे बैठ रहे हैं तो सर एक फोर्स मतलब हम फिर एक्सेलरेशन को इस वजह से ऑब्जर्व नहीं कर पा रहे क्योंकि हम पे भी वही सेम एक्सेलरेशन एक्सर्ट हो रही है सो इन अगर हम उसी फ्रेम में से देख रहे हैं लाइक 1 2 3 1 2
no,
वाले फ्रेम में से तो हमें एक्सेलरेशन 0 दिख रही है पार्टिकल
acceleration is 0 in the relative frame, in the moving accelerating frame. But if you want to apply Newton's second law, can you say that m acceleration 1 2 3? Can you say this? Because you know this is 0.
नो सर बिकॉज हम क्योंकि न्यूटन्स लॉ आर वैलिड्स ऑन नॉन इनर्शियल फ्रेम तो अगर हम इनर्शियल फ्रेम में जाते तो सर हमें सूडो फोर्स या ऐसा कोई कंसेप्ट
That
इंट्रोड्यूस
is why I am applying this pseudo force. Whatever is the acceleration of the moving coordinate system, that I am giving to the particle with a minus sign. So this is known as inertial force. If you want to analyze the motion of the particle in that accelerating frame, you have to add this force. Now you can get acceleration equal to 0 in that accelerating frame. Can you see this? Because of this addition of this pseudo force or inertial force. If you want to consider an accelerating frame, this is what you have to do. We will do it later tomorrow, next class also, because I will have 2 hours and I will need to explain more thoroughly. The class is over.
ओके सर थैंक यू सो